Boom! Hey, how are you? So we come in again, and this is the final video in the series on the addition and the subtraction of fractions. In this video, we're looking at the specific case of two denominators that are different. But unlike in the previous video, where we dealt with the case of a clear relationship between the two, in this case, there's no clear relationship between the two, which means that we have to do something else, something different to what we would have done in the previous video. So, examples again. 3/7. We're sticking with the 3/7. And this case, we add in, let us say, 3/7 plus 8/11. Look trouble. All right. 7 and 11. What do we do in a case like that? In a case like that, what we do, because there's no clear multiplicative relationship between the two, 11 is not a multiple of 7, and 7 is not a factor of 11. Because there's no clear relationship between the two, we have to do something else. And what we do is that we look for some other number. We look for some number that is a multiple of both 7 and 11. So in other words, if 7 and 11, if there's no connection between the two, then we have to look for a number that connects the both of them in a, again, what we say, a multiplicative relationship. So if we don't have a multiplicative relationship between the two, we need to look for that multiplicative relationship in another way, in another form. And we do that by, guess what? We multiply the 11 by the 7. So in other words, when we multiply 11 by the 7, what we are in effect doing is establishing a different type of multiplicative relationship between the 11 and the 7. Right? That is something that you might recognize as finding the LCM, which is an acronym that means the lowest common multiple. Right? L for lowest, C for common, M for multiple. Right? And anytime you have two numbers that they're not connected directly, in other words, there's no factor multiple relationship. You can't look at them and say, well, one number is a factor of the other one, or one number is a multiple of the other one. If you don't have that, then what you do is you just multiply the two numbers by each other. You multiply the two numbers by each other, and when you do that, what you actually have is the lowest common multiple. So what's the lowest common multiple of 7 and 11? 7 by 11 is 77. Alright? So 7 multiplied by 11, we multiply the 2. Right? Now, as you get more familiar with these things, this is something that you'll be able to do in your head, of course, if you know the tables. 7 by 11, you know that's 77. But for teaching purposes, I will write it out step by step on the board. So 7 by 11 is equal to 77. Kind of funny looking 7 there, boy. Alright, we'll make it better next time. Right? 77 is the lowest common multiple of 11 and 7. Now, what this now allows us to do is that we can now write both of these fractions as fractions where the denominator is common, LCM, common, yeah? And that common denominator is 77. So if we could write these two fractions, if we could rewrite these two fractions in a form where both of them have a denominator of 7, then we're done. We're done. Right? Now, in the previous instance, where one was a multiple of the other one, we only had to change one fraction. Because you have 7 and 14 as the denominators. So if you change the one with the denominator of 7, you multiply the numerator and the denominator by 2, you get a fraction with a denominator of 14. Same thing with the 3 and the 21. 3 by 7 is 21. So if the denominators are 3 and 21, and you want to find a common denominator, then you just multiply the fraction with the denominator of 3 and multiply the numerator and the denominator by 7. And you now have a fraction with a numerator of 21, and you continue. In this case, however, because we don't have that direct multiplicative relationship between the 7 and the 11, we multiply them by each other to get a different kind of multiplicative relationship, this time involving a third party, the number 77, which is the LCM. It means now that we have to actually alter the appearance of the both fractions as opposed to one in the previous video. So in the case of 3 over 7, 7 by 11 is 77. So what do? We multiply the numerator and the denominator here by 11. So we say that this is what? 3 over 7 is equal to 3 by 11 over 7 by 11. Yeah, right? 3 by 11 is 33. 7 by 11 is 77. So 3 over 7 is the same thing as 33 over 77, which we could kind of see instinctively, right? You multiply the top and the bottom by 11 and you get 33 over 77. By the same token, you have 8 over 11. And you want to alter the appearance of 8 over 11 to change it into a fraction where the denominator is 77. So it's like, it have some cartoons and some stories, movies and things now, books and things, where you have some character. It might be a witch or a sorceress or a magician or something. And the person has the ability to alter their appearance. So they could shape-shift them, so to speak. They could change themselves to look like anything that they want to look like. That's the same idea we are applying here. We change the appearance, but the essential fraction remains the same. In the same way that a magician, if he changes to something or somebody else by appearance, excuse, it's the same person that you're dealing with. Mightn't look the same, but it's the same. Alright? So 8 over 11 is equal to what? 8 by 7 over 11 by 7. 8 sevens are 56. 11 by 7 is 77. Right? Now, we can write 3 over 7 plus 8 over 11 as, we can say that is equal to 33 over 77, excuse, plus 56 over 77. And once we have commonized the denominators, I'm not sure that is a word, but I'm using it anyway. Excuse. Yeah, coughing, but I'm leaving the video just like that. Right? Once you have commonized the denominators, you could just add the numerators. So 33 plus 56 is 6 and 3 is 9, 5 and 3 is 8, 89 over 77. End of discussion. Excuse. Alright? And of course, the same pattern applies if you're subtracting. So let me do the same thing with the 3 over 7. If we have, we're changing the color of the ink now, right? if we have not 3 over 7, sorry, 7 over 3. We now have 7 over 3 minus, let us say, 7 over 3 minus 4 over 13. Nice numbers, boy. Yeah? 7 over 3 minus 4 over 13. Right? Again, there is no clear multiplicative relationship between 3 and 13. In other words, 13 is not a multiple of 3, and 3 is not a factor of 13. So just as we did in the case of the 7 and 11, we go for a third party. We don't have a direct link between the two. So you invoke a third party. Again, it's just like humans when we relating to each other. Sometimes you have two people who there's no real direct connection between them. But they had to deal with each other. There's some kind of interaction that must take place. And sometimes the only way to effect that is through the invocation of a third party. You bring the third party and boom, everybody connected and boom, you get done whatever you had to get done. It's the same story here. The 3 and the 13, there's no direct link between the two of them from a multiplication standpoint. But if we multiply the 3 by the 13, we now have ourselves an LCM, a lowest common multiple, which allows us now to express both of these fractions with a common denominator of 39. Alright? We know that 3 by 13 is 39, so your lowest, so your 3. 3 by 13 is 39 as the LCM. So we could now see that, let me see, let me try and squeeze in the bottom here. We could now say that 7 over 3 is equal to 7 by 13 over 3 by 13. 7 by 13 is 91, 3 by 13 is 39. Yeah? And by the same token, we could say that 4 over 13 is the same thing as 4 by 3 over 13 by 3. 4 by 3 is 12. 3 by 13 is 13 by 3 is 39. So we have now expressed 7 over 3 as 19 over 39. And we have expressed 4 over 13 as 12 over 39. So again, the appearance has changed, but the value remains the same. The form has been altered, but the substance remains as is. Which now allows us to write this over as, this will be what, 91 over 39 minus 12 over 39. 91 minus 12 is 79. 79 over 39. End of conversation. Yeah. So over the course of these 3 videos, you would have seen that the central theme, anytime you're adding or subtracting 2 fractions, the central theme, the underlying principle is that the denominators must be the same. Now, you would have either one of 2 situations. You would either have situation 1, where you're starting off from the outset with the denominators being the same, which we dealt with in the first video. You just add or subtract the numerators. So you perform your arithmetic at the level of the numerators if the denominator is the same. And then the second option is that the denominator wouldn't be the same, in which case you now have to do something to make the denominators the same. And in the course of doing that, you have to look at the relationship between the 2 denominators to see if there's a clear multiplicative link between the 2. If one is a factor of the other one or one is a multiple of the other one. You make a particular change. We covered that in the second video. And in the third video, this one, we covered the case where there was no clear multiplicative relationship between the two denominators, which is to say we do something else, which is we find the LCM, the lowest common multiple, to give us the same effect, which is to make the denominators common. So in other words, when the fractions do not have the same denominator, in other words, they're not in the same denomination, we have one of two choices. We could either change the denomination of one fraction to the next, right? Or, that's the second video. Or, in the third video, what we did is that we changed the denominations of the both fractions to a common denomination. So, in other words, if we want to use an analogy, let me say two people get married to each other. Different denominations. So in other words, let me use the analogy. Let me make the thing nice. Right? Let me say two Catholics decide to get married to each other. And I'm using the specific case of the Christian faith here because there are a lot of denominations of Christianity. And I'm not trying to be religious or anything like that, because I am sure that there are other denominations of other religions. But I don't want to talk too much about things that I don't know about, that I'm not familiar with. Right? So let me stick to our religious kind of setting again. I'm doing this as a means of trying to drive home the point, trying to make the thing come alive. Right? The very word denominator, denomination, same root, same idea. So two Catholics get married, same denomination. So in other words, that is like the situation where you have two fractions with the same denominator. No problem. Well, generally speaking, we're not going into the specifics of what has happened when people get married and things. Right? What about if a Catholic get married to a Presbyterian? Different denomination. Right? But all under the same umbrella, nominally, of course, of Christianity. Different denominations. So one of two things happens. Either the Presbyterian convert to being a Catholic, or a Catholic convert to being a Presbyterian. So in other words, one party change denomination to be the same denomination of the other party. And what about, you might have a hypothetical case where, let me say, a Pentecostal might marry to a Baptist. Different denominations. And then somewhere along the course of the relationship, both of them decide that they now want to become Anglicans. So now you have a common denominator. Yeah, I try something, right? Right? Sometimes you have to use non-mathematical examples to kind of make the thing a little clearer. Right? So the idea of things having a common denominator or common denomination is a theme that runs through a lot of things. We just spent 3 videos exploring the case of fractions, where you have same denominator, with a little relationship between the two that allows just one to change to become the same denominator as the other one. And then in the third case, where the two denominators are the same and they're different. And by virtue of the fact that there's no clear connection between the two, you have to do something to the both of them to make the denominators common. So I trust that this series of 3 videos would have helped to clarify the issue And like anything that you learn in life, you have to practice it. So the next step is to practice. To practice. Find exercises, find questions that deal with the different aspects of the fractions. Practice. And then when you practice and you get the hang of it, you use it and you run down the road. And you advance your journey on the mathematical road. So stay tuned. We have plenty more coming.